Okie dokie. So for today, what we are going to be doing is we are going to be reviewing absolute value. And fractions. This correlates with homework, which is number 101, and today is the 18th. Okie dokie. So a couple things we need to remember here. The first thing we need to remember is what is absolute value. So absolute value is the distance a number is from 0 on a number line. So I want to remind you guys that we cannot travel a negative distance, therefore absolute value can never be negative. We always need to make sure that we get down to a single digit. There should be a single digit inside the absolute value bars. These are what absolute value bars look like. So inside the absolute value bar.
Michelle?
Yep.
My internet just crashed in the middle of the test, and it was just stuck.
Okay. So again, a single digit inside the absolute value bars, that's what we want to get down to. I want to remind you guys that absolute value bars, so absolute value bars, this would be a grouping symbol. So when we talk about GEMDAS, absolute value bars count as grouping. And then anytime I write something that is an S and an exclamation point, that means to simplify. So these are some quick review about absolute value. You should know this. This is from course 2 and also course 3. So here is like example 1. I might have something that looks like this. So I would read this as the absolute value of 2 minus 4. Now I want to remind you that in math, we systematically show every single step. So we need to show step by step simplifying, getting down to the answer, and then boxing it. So the first thing I'm going to do is simplify what is inside my absolute value bars. So I should have an equals, and 2 minus 4 is going to equal negative 2. I have one digit now inside my absolute value bars, which means that I can simplify again. So the absolute value of negative 2 would be a positive 2 because it's 2 away from 0 on a number line. Box it, I am done. Here is example 2. Ooh. Okay, example 2 looks like this. Now, when I read this, I don't read it as negative of absolute value. I read it as the opposite of the absolute value of 7. So this is the opposite of the absolute value of 7. So there's only one digit inside here, which means that when I simplify, this becomes a negative touching 7. Which would essentially be the same thing as a negative 1 times 7. So therefore, it is negative 7. And that is the opposite of the absolute value of 7. Here's my last example. So example 3. Example 3 looks like this. The opposite of the absolute value of -9. So first thing I'm going to do is I'm going to simplify what is inside my absolute value bars. So this is going to create a negative, and then I have -9 absolute value, which is 9. So now I have a negative times 9, which is going to give me a -9. And I box my answer. So you can see here that I have my mathematical syntax where all my equal signs are lined up. I'm doing a systematic step-by-step showing all of my work. Those of you that have had me before, you know what the expectation is as far as this is what it needs to look like. For those of us that haven't had me before, this is what your stuff needs to look like. Okay, and then we are going to move on to take a look at fractions. Again, fractions are something that you should be familiar with. I'm going to go ahead and give you a quick overview of stuff we should know about fractions. So here is my quick overview. In order to add fractions, I need to come up with a common denominator. One of the ways to use that is, or to find that, is to use the least common multiple. So I would take 8 and I would take 12. I draw the letter L for least common multiple. I think to myself, what do these two numbers have in common? Meaning, what is a shared factor? It would be 4. 8 divided by 4 is 2. 12 divided by 4 is 3. These do not have anything in common, so I circle my giant L. Then I say my least common multiple is equal to 4 times 2 times 3. So I'm multiplying everything in this L, which ends up creating 24. Then I come back over here and I'm going to make these fractions have a common denominator. So I have 3/3 times 3/8 plus 1/12 times 2/2. I'm multiplying this by 3/3 because 8 times 3 is 24, and I'm multiplying this side by 2/2 because 2 times 12 is 24. I want to remind you guys that in order to create a common denominator, we need to multiply by a giant power of 1. A giant power of 1 is when the numerator and the denominator are the same number because it creates one whole. From here, I'm going to go ahead and simplify, which means I have 9/24 plus this makes 2/24. I can combine and I have 11/24. No common factors shared there. So I am going to go ahead and there you have it, box my answer. Now, I know some of you are wondering, why are we doing it like this? And the reason why is because we are going to end up with some larger numbers that are a little bit harder to solve. So I'm going to go ahead and do an example of that now with you. Let's say I have 142/270 plus 357/504. Those are some really ugly numbers. Really ugly numbers. And in order to find the least common multiple of these numbers might be a little bit more challenging. So I'm going to show you another way to do this. Let's say I have 270, and let's say I have 504. So what I'm going to do here is I'm going to write these numbers out as a product of primes. And one of the ways to do that is to figure out like what this is made of. So 270 is made of, let's say, 27 times 10. So 27 would be 3 times 3 times 3, and 10 would be times 2 times 5. I've now written this out as a product of primes. I'm going to look at 504. 504 would be, let's say that's divisible by 2. So I'm going to start with a 2. That goes in to make what? 252. Does anybody know what 252 is made up of? Cricket.
25 multiplied by.
No, it'd be a 25. So if I have 504 and I'm factoring it, 504 is the same thing as 2 times 252. So if I was to factor 252, that would be like another 2 times what?
126.
126?
Yes.
Okay. And 126 could be 2 times 63.
Yeah.
And 63 would be 7 times 9.
Mhm.
And 9 is 3 times 3. So I end up with 2 times 2 times 2 times 7 times 3 times 3. That would be my product of primes. Now I'm going to look for matches. So what I mean by that is when the numerator and denominator match. And I'm going to circle those. So I have a 2 and a 2. I have a 3 and a 3 and a 3 and a 3. So anything that is circled, I am going to basically leave alone for a minute. So I'm going to look at what's left here. On 270, I'm left with a 3 and a 5. That means I'm left with 15. And on 504, I'm left with 2 times 2, which is 4, times 7, which is 28. So I'm left with 28. Now what I'm going to do is I am going to take the numbers and multiply with what's left over. So I'm going to come over here and I have 142 over 270 times 28 over 28 plus 357 over 504 times 15 over 15. Because everything else that's shared in common, I don't need to use in order to come up with this common denominator. Then, I'm just going to move some of my scratch work real quick so I have space. Then what I'm going to do is I'm going to multiply these out. So I have 142 times 28. I have 357 times 15. And I'm going to have 270 times 28. Okay? These three will give you the next step for what we need. So I'm going to go ahead and start working those out, as should you. Remember, there are no calculators. So I just want to remind you all of that. So I should end up with a fraction that looks like this. So now I need to start simplifying. So I'm going to go in here and I am going to add these two numerators together, which is going to end up giving me 9,331 all over 7,560. And then from here, I need to figure out what these are both going to be divisible by, which is kind of tricky to do, right? Because these are really big numbers. So if we go back to our work over here, you can see that on this side, I multiplied by 28, which is like multiplying by a 7 and a 4. And then you can see here that 504 is also made up of a 7. So we could figure out from there that both of these are divisible by 7. So this would be like 7 times, so if I divide this by 7, I'm left with this, and I have 7 times this. So I go ahead and these simplify themselves out, and I am left with this number here. So that is how you work out a very, very ugly, unfriendly fraction, which is essentially the same thing we did with nice fractions in the past.